Okay, here are the notes for section 3.6. So this should be the Thursday, Friday notes. And 3.5, I talked about this a little bit, talking about the fundamental theorem of algebra. And basically, what it says here, if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution. Okay, now that's great. Basically, I mean, that's kind of what I said before, but the corollary is the part that's really important for the fundamental theorem of algebra, which says if f of x is a polynomial of degree n, then the equation f of x equals 0 has exactly n solutions. So what that means, if I have something to the power of 3, I can get 3 solutions. Now, sometimes they're real, sometimes they're imaginary, but I'm going to get 3 types of solutions. If I had something to the 10th power, I would get up to 10 solutions. Now, we're not going to do anything that's that big, but that's basically all the fundamental theorem of algebra is. If we had something to the first power, we'd get 1 answer. Okay, now solutions don't necessarily mean they're like 2 or 6. They can also be strange looking things like 1 plus root 3 or 1 minus root 3. Or as we're going to learn here with the complex conjugates theorem, if f of x has an imaginary solution, okay, it can have imaginary solutions with i's in them. If it has an imaginary answer of a plus bi, then its conjugate, a minus bi, is also a solution. Okay, so we're going to look into some problems that look at some things like this. Okay, now if you guys need to pause this to write some of these things down, but the basic idea talks about these two things. The corollary is probably the most important part. This one just says if it has an answer where n is greater than 0, you're going to get at least one solution. Well, okay, great. So now let's get into, here's the first example that I want to go over with you guys. Example 1 is find all the zeros of the function. And I also got a calculator so you guys could see where I'm going to get some of these answers from. Okay, find all those zeros of the function. And it gives us this. X to the 5th minus x to the 4th minus 7x to the 3rd plus 11x squared plus 16x minus 20. Okay, so it's pretty long. Okay, now the first thing I want us to look at is obviously when you look at, they don't share anything in common. It's not a trinomial. You can't use grouping. Okay, so the only option that you have is the p over q thing. Okay, now the p over q thing, remember that p is the value, the constant that's at the end, and the q value is going to be the leading coefficient for your biggest power. So I'm going to put the plus or minus 1 on the denominator and make a list of my factors of 20. Okay, so I'm going to use plus or minus 1, plus or minus 20, plus or minus 2, plus or minus 10. And then we also have 4 and 5. Those are going to be a list of all the things that we have. Okay, so that's going to leave quite a lot of possibilities because when we divide this, all of the numerator answers are all possibilities. So I'm going to write them out. These are all the things that we can possibly choose from as being solutions. Okay, so when we go to start this, let's, I'm going to pull out the calculator here. Okay, turn this guy on. Now, hopefully you guys have a calculator. If you don't, you might want to use Desmos or any kind of online thing that you can find. You can open up an app, put an app on your phone that will do graphing features. So we're going to go to y equals. I'm going to clear all this stuff out, and let's enter the long function that we have. X raised to the 5th, hit the little right button so it gets off the power, minus x to the 4th, okay, minus 7x to the 3rd, plus 11x squared, plus 16x minus 20. Okay, so we have that whole long thing there. Okay, now my window is set on my normal window, and I'm just going to hit the graph button because all I need is 1 point. I just need to know 1 point that it could potentially cross. Okay, it's got a lot of things that are happening. Okay, now remember end behavior. This is going to be the same thing as y equals x to the first, or x to the third, x to the fifth. I bet you that this part's going to go down and this part's going to go up. And then we just got to find locations where it looks like it crosses. Now, I'm gonna zoom in a little bit on this window instead of making it negative 10 to 10. Let's make it negative 5 to 5 so we can get a little closer picture of where it looks like it's crossing. It really looks like it's crossing at negative 2 and 1. Okay, those are two numbers that are really strong possibilities. So let's try negative 2. Now keep that in mind. I'm going to write negative 2 and 1 on here because these are looks like we're places that they're crossing. I'm going to put zeros and write question mark. That's just from using an educated guess from looking at the calculator. Okay, so I am going to pick negative 2, and I'm going to make the list of my coefficients. 1, negative 1, negative 7, 11, 16, negative 20. Now, one of the things I want us to kind of look at, it looks like it crosses negative 2 and its tangent, which could be what's called a turning point. Okay, so keep that in mind. Negative 2 might actually work twice. So now we're going to go and plug these little guys in, and we're going to see what values they create. Now, the fundamental theorem of algebra states we have a power of 5, so we're going to get 5 solutions. Okay, so let's pull this down. Multiply, add, multiply, add, multiply, add, multiply, add, multiply. Okay, cool. We got a 0. Remainder, constant, x1, x2, x3, x4. We found one answer. Now, since we had a turning point at negative 2, that means that another negative 2 should work as well. So let's take all those numbers that we got for the problem prior, and let's do it again. So pull this guy down, multiply, add, multiply, add, multiply, add, multiply. Hey, we got another winner. Remainder, constant, x1, x2, x3. Okay, 2 solutions. Now, it doesn't matter that they're the same. There's still one. There's going to be 2 of our 5. Okay, now the next one we want to pick is 1 because 1 was one of our possible zeros using the same numbers. So we pull this guy down, do the same thing. 1, negative 4, 5, 5. Remainder, constant, x squared term. So there's 3 of our answers. The last little bit, this is x squared minus 4x plus 5 equals 0. And we can use the little x thing to figure out what the last remaining answers are. So we have a 5 and a negative 4. We need to find numbers that multiply to make this, that add to make this. So let's try. Well, it doesn't look like that's going to work. Okay, it'd be a nice little guess. The problem is those add to make negative 4, but they don't multiply to make 5. These are the only things that multiply to make 5, which basically doesn't work. The x thing won't work. So we have to use the quadratic formula to get the last answers. Okay, now, yes, these are a lot of work, but it doesn't mean that they're not impossible. They're just things you got to practice and you got to keep working. Okay, so, and this is going to be important because sometimes the answers don't come out pretty. The A is 1, kind of like the number we had here. The B is negative 4. The C is 5. Take all these numbers and plug them in. Okay, so the opposite of negative 4, plus or minus the square root of negative 4 squared minus 4 times A times C, all over 2 times 1. Okay, so all I've done, I've taken these numbers, I plugged them directly into the quadratic formula. This is the quadratic formula. Okay, the reason I'm using the quadratic formula is because this won't factor. There was no values that multiply to make 5 that add to make negative 4. So to get the answers, I have to plug it into this, which you guys have done in Algebra 1, you did in Math 2, and now it's showing up again. Okay, so I'm going to figure out the answer for the discriminant first. The discriminant is the thing that's underneath the square root. This makes 16 minus 20. 4 times 1 is 4 times 5 is 20. Now, if I put those together, I get an answer of negative 4. This makes positive 4. So I get 4 plus or minus the square root of negative 4 all over 2. Well, something that you guys may remember, when you take the square root of a negative number, the square root of 4 is 2. You stick an I on it. Anytime the square root of negative 1 is equivalent to I. We know the square root of 4 is 2, and then the negative comes out as an I. You can divide the 2 into both, and you get these two additional answers. 2 plus I, 2 minus I, and 1, and negative 2, and negative 2. So just to kind of sum up what this means, this is telling us we still have 5 answers, these 3 plus these 2, but these are the only real answers, and these are the 3 that cross the x-axis. And if you go back to your picture of your calculator, there were 3 locations of where the graph crossed the x-axis. Now, we could go further down, and there's a little bendy thing down here, but those are the only spots where they cross the x-axis. These are solutions, they're just not real. Okay, imaginary solutions. So the question said find all the zeros of the function. We found those 3, and we found those 2 as well. So these are all 5 of the zeros. So if I were to write them down, I'd write this and this. Okay, now you can actually write out negative 2 twice. You could write it like that if you want to see it listed as all 5. Okay, but if you just wrote it like that, I would accept it. The double minus 2's represent that it's crossing. It was a turning point. Okay, so that's the first example problem. Let's try one that's similar to that one. Okay, we're going to do another example. There's only 2 examples for this, but I think with a lot of practice with these, and you guys learn how to use the calculators, or if you download an app, there's some good work here. Okay, it says this example has 2 parts. Write a polynomial function of f that has the given zeros. Okay, and here's part A. That's all it gives you. I and 4, and that's it. Okay. The rule that we had talked about earlier was called the complex conjugates theorem. So if A is an answer, that means that we're also going to have another answer for it as well. Okay, that is also going to be negative I. Because you can think of I as being like 0 plus I. And if you wanted to find the conjugate of that, 0 minus I. And you don't have to write the 0. Now, sometimes it's written like 3 plus I, and that would be 3 minus I. But in this case, it's just I. So we have these 2 plus 4. Now, 4 is the easiest one to write out. It's obviously x minus 4. But when you write out these guys, this is going to be, for this one, it's x minus I. The value that makes this 0 would be an I. And then x plus I. Okay, so our job from here is now to FOIL these things together. Okay, now you kind of have to go back to what your definitions are. Okay, and I know you guys did this in a prior class, but that's the definition of I, the square root of negative 1. So we're going to start off by using FOIL. We're going to multiply the x's together. That makes x squared. The outer terms, when I multiply these together, I get x times negative I, which is negative ix. And inner term, I get I times x, which is positive ix, and they drop out. Now, the definition of a conjugate means that all of these secondary terms in the outer and the inner are going to drop out. They have to, okay, because we don't want to have anything nasty in there. And then the last part for L is I times negative I, which makes negative I squared. Well, if you think about it, I is the equivalent of negative square root of 1 squared. Well, if I square this, it just makes an answer of negative 1. With a negative in front of it, makes that whole answer positive 1. right? Because if I square this, it's just negative root 1 times another negative root 1. Okay, it's the same. Oops, this is right here. Okay, it undoes itself when you square the square root of negative 1. When they're the same thing, it just comes out as negative 1, but there's a minus in front of it. So this whole thing becomes x squared plus 1. Think of it this way. These undo themselves to make negative 1. It's the same reason that when you multiply root 6 times root 6, it makes 6. Okay, root 100 times a root 100 is 100. So if you guys have something where they're the same, they undo themselves and just come out as a negative. So you got to multiply x squared plus 1 times x minus 4. And we're going to FOIL this again. So you multiply those. You get x cubed. Multiply x squared times negative 4. You get negative 4x squared. I stands for inner. This makes 1x. And L for last, 1 times negative 4 is negative 4. Combine like terms. Well, none of them are the same. So just make a list in order, starting from highest power to lowest power, and you're done. Now, this may seem crazy, but if I plugged a 4 in here and I set it equal to 0, that would zero out. But also, if I were to stick an I in here, they would also zero out, or a negative I. So that's the equation, a polynomial function of f that has these given zeros. Okay, now, and I did, that example is also on the notes. If you go to Google Classroom, I put the notes portion on there as well. So if you need to, rewind this, take a look at it, stop it, pause it, all that good stuff. Okay, part B. Okay, this is same type of problem. 4 and 2 plus I. Okay, now we used 4 last time, so why don't we just pick another number? I'm going to pick, how about 5? It's a little different than I was just picking the ones that I put on the paper, but I'm just going to do a different one. Okay, so let's say this is x minus 5. And if 2 plus I is one of the answers, its conjugate also is, which is 2 minus I. So when I write this guy out, it's x minus 2 plus I. And when I write this one out, it's also x minus 2 minus I. Okay, and let me put another parentheses on that. All right. So just like I did the prior problem in the last section, I have to distribute the negative to both of these things. Now don't forget the x minus 5 is still sitting over here. It hasn't done anything. But this guy will become x minus 2 minus I. And then this guy, when I distribute it, will become x minus 2 plus I. That's just distributing the negative to both of these and the negative to both of these. Okay, so now I'm going to start off by multiplying the x minus 2's together. That makes x minus 2 squared. Now, if I multiply this together, it makes negative ix, and this one makes positive ix. Okay, those are going to cancel. They're conjugates. The last little bit, when you multiply the L portion, you get negative I squared. Well, remember that this is just a fancy way of writing negative 1. We got that from this guy that we did earlier up here. I squared made negative 1. Keep that in mind, okay, because that could come up again. So now this guy, when you go to factor this is x minus 2 squared and then plus 1, because it's the opposite of negative 1. Now we have to simplify this. This is x squared. You square the first term. You square the last term. You multiply these together and double it and add 1 to it. We have that times the x minus 5. Okay, so to recap what we've done, I changed the 5 into x minus 5. I changed the 2 plus I into x minus in parentheses 2 plus I, and this one, the 2 minus I, into x minus 2 minus I. I distribute the negative to both of them. It gives me this whole thing. Now, I FOILed them, kind of like putting the x minus 2 in parentheses. This was my first term. My outer and inner terms will drop out, and my last term is negative I times I, which is negative I squared. The value of I squared is negative 1. The opposite of negative 1 was 1. I simplified this. Square the first term, square the last term, multiply these together, double it. Add the 4 and the 1 together, get 5. Now, I need to multiply everything. X cubed negative 4x squared plus 5x. That's just the x to everything. Now I also have to do the minus 5. Negative 5x squared plus 20x negative 25. This guy stays first. That's second. That's third. That's last. There's your answer. Okay, now we've done, these were the examples, all the things for the next section. Now, I'm sure when you guys come back, there's going to be questions, and I'm going to be more than happy to go over things with you guys about things that we don't understand, and we'll do office hours and all that wonderful stuff, especially for people that don't understand how to do things from these sections. If you guys want to send me emails, I can try to answer them, but I won't really have any Zoom capabilities, but I can try to answer some questions. Use these things, okay? Go back, pause it, look at it. If you need to, just send me some messages. There's also some other teachers that might be available, or you can talk to some other students about the homework. All the Math 3 students should have the same homework. So you guys are doing the same thing as the other classes are doing, okay? So don't think that you're getting, I'm giving you more homework, less homework. It's the same. We're doing all the same notes. The same notes that I'm giving you, that all the other teachers are using it, and they're putting on their Google Classrooms as well. Same example problem, same everything. Okay, guys, I will talk to you later. Hope you guys have a good week.